Okay. No, you're not. No, I don't want you to feel like that. I just know after yesterday, I was a tad bit nervous in the fact that we didn't know even how to start some of them. Okay, so that's a scary thought. And then I'm getting messages at like 11 o'clock that says, "Oh, can you go over this one?" I'm like, "No, we have." If I spent all time doing that, would you guys really be ready for the quiz today? No, because there's not that many. I understand that you guys are busy and I get that, but we got to make sure we're using our time wisely. Is that fair? Okay. Hey, Courtney, will you turn the lights off for me, please? Thank you. Okay, so using the sum and difference identities, condense each. So you're gonna be given the identity, you need to go back to the basic, and then express it as a single angle. Okay? So if we look at number 1, is that sine, cosine, or tangent? That's sine because you have sine and cosine together. Right? Is it sum or difference? Sum. That's as fast as you need to figure that out tomorrow. Okay? So you know this is the sum using sine. So you would write this, that is the sine of what? Or I would say it's the same as the sine of 140 degrees. Right? No calculator. You got to do that on your own. Now, can you express this? Can you find the exact value of that? Is 140 degrees an angle that we know? No. Because 30 and 60 don't go into it, right? Okay, clearly 45 doesn't. 2, sine, cosine, or tangent. This is cosine. Is this sum or difference? This is difference because it's being subtracted. So this is the cosine of what angle? 72 minus 130. It's negative 58 degrees. If you have to on the side do that math on the side. Okay? It won't take you that long to figure that out. Yeah? 3, sine, cosine, or tangent. That's tangent, yes. Is it sum or is it difference? Why is it difference? You can look at the denominator. I actually always look at the numerator. If it's subtraction up top, I know it's subtraction or the difference. It doesn't matter. Either one. So I know it's the difference. So this is the tangent of 80 degrees. You could either write it with parentheses or without. So that's sum and difference using degrees. Are we okay with those? I think those are easier than the radians. Yes? Okay. Now, on 4 and 5, I give you the angle, and you need to find what you would add or subtract to find that angle. So the first one is negative 105 degrees. Well, we know it's negative, so we know we probably have to what? Subtract, right? If it ends in a 5, what angle are you automatically going to use? 45 degrees, correct? Now, I usually go, okay, take that, and I know I'm going to do 45 with it. But do you want to use negative 60? Because that's not an angle that's on your chart, right? Is negative 60 an angle on your chart? No. No negative angles. 45 minus what is 105? So if I were to ask you that, on like an algebra 1, that's an algebra 1 thing. So I would have said, okay, I know 105, negative 105 equals 45 minus x, right? That's what we're trying to find, correct? Well, how would I solve this? I would subtract 45 over, correct? So it's negative 150 equals negative x. So what is my angle? 150. Is that an angle you know off your chart? Yeah, because which of my two angles that I do use goes with 150? 30, right? 60 doesn't because it'd be 60, 120, 180. Does that make sense? Okay, 30, 60, 90, 120, 150. Yes. No, because, well, I would divide by negative 1. This is, but yeah, it's fine. So I would write this as the tangent of what has to be my alpha angle? 45. Don't use pi over 4. I'm going to be picky about this. If it's in degrees, it needs to stay in degrees. Okay, so 45 minus what? 150. Soon as you have that, what can I do? I can use my formula, yes? So this is the same as the tangent of 45 minus the tangent of 150 divided by 1 plus the tangent of 45 times the tangent of 150. Sorry that it's taking so long. Is everybody cool with me there? Now, 45 degrees is what angle that you recognize? It's pi over 4, right? What's the tangent of pi over 4? It's 1. So this is going to be 1 minus 150 degrees. It's definitely not on your little chart. Here's how I think about this. I know 30 went in there, right? So watch. 30, 60, nobody's watching me, which is a problem. 30, 60, 90, 120, 150. How many times did I add 30? 5, right? And 30 degrees is pi over 6. So 150 degrees is the same as 5 pi over 6. Now, does that make sense? Because 5 pi over 6 is in what quadrant? The second, right? Because it's 1 less than the denominator. Is 150 degrees also in the second quadrant? Okay? So, what is the tangent of pi over 6? That would be a radical 3 over 3. And in the second quadrant is what? Negative. So I'm going to say I'm going to add radical 3 over 3. That process that I just walked you through right there, guys, that's exactly how I do it in my head. So if I could give you a hit tomorrow, as soon as you get your quiz, what are you immediately going to put on there? You're going to put your chart if you need it on there. But the more you memorize that without having to write down, the easier it will get. Okay? Now, I'm going to divide that. 1. Now, it says plus, right? But these two I've already found, correct? This is 1, and this is negative radical 3 over 3. Agree? So if I multiply them, I get negative radical 3 over 3. This is where some of you got stuck on letter E. Okay? You have to find a common denominator first before you do anything else. What is my common denominator? 3. So this becomes, gosh, she's so good at this. 3 plus radical 3 over 3. Right? Does everybody agree with and understand how I got that? So my original denominator here is 1. Yes? It now became a 3. So I have to multiply them 1 by 3 as well. It's 3 because that's the only thing that's in my denominator. Of my numerator. My common denominator for my denominator is also 3. So this is going to be 3 minus radical 3 over 3.
So why is it 1 plus radical 3?
Because the tangent of 45 degrees is 1. And the tangent of 150 degrees is negative radical 3 over 3.
So shouldn't it be 1 minus negative?
But it's 1 minus a negative radical 3 over 3. Because the formula has to be subtraction up here. It becomes addition when you're in the second or fourth quadrant. Does that make sense? Hopefully everybody's kind of figured out. If your denominators are the same, they cancel. Hopefully we kind of remember that from Algebra 2. Because if you multiply by the reciprocal, they cancel. So now I have 3 plus radical 3 over 3 minus radical 3. Yeah? What must I do now? Multiply by the conjugate, which is 3 plus radical 3. If you get this one wrong, tomorrow I'm going to make fun of you on Monday. No pressure. Now you just have to distribute. So I have 9 plus 3 radical 3 plus 3 radical 3 plus 3. All I did was distribute the top. Yeah? If I'm going too fast, tell me to slow down. Divided by 9 minus 3. Remember, in that denominator, you multiply the first two and multiply the last two. We all good in the hood there? What am I? Yeah, I'm sorry, what?
When you multiply it, how come it's 3 plus radical 3?
Because you would do 3 times a positive radical 3. Why is it not a plus down here?
Like you multiply the 3 plus radical 3, wouldn't it be 3 minus?
Where?
Like
numerator, denominator.
The denominator.
3 times 3 is 9.
Or no, I mean like you multiply 3 minus negative 3, which is the denominator, and the step above the answer.
Here?
Yeah.
Well, in the numerator would, so 3 and 3 is 9. 3 and radical 3 is 3 radical 3. Radical 3 and 3 is 3 radical 3. Radical 3 and 3 is 3. Down here, is this what you're talking about?
Yeah.
3 and 3 is 9, right? 3 and radical 3 is positive 3 radical 3. But if you do negative radical 3 times 3, that's negative. They would automatically cancel. The conjugate, as long as you split that sign, you always just multiply the first and the last. Did that clear that up? Because it doesn't look like it cleared it up.
Kind of.
Yes, it does. It matters a lot.
I'm wondering how come you cancel, because there's a radical 3 in the denominator, right?
Yes.
And to cancel that, I thought you had to multiply the 3 minus, and you multiply the 3 plus radical 3.
No, you always have to switch the signs. Your conjugate is the exact denominator, except you have to switch the signs. Because if you multiplied this by a negative, you wouldn't get rid of your radical in the denominator. You'd have negative 6 radical 3. Just make your denominator even grosser.
Can you do that one more time?
Can I do what?
The denominator, how you just got 9 minus 3.
So 3 and 3, 9, yeah? Negative radical 3 times radical 3, that's negative radical 9. Square root of 9 is 3. Just first and second. Agree? 5. The sine of 345 degrees. What? Why are you doing 30 times 10? What did you say? Did you do 300? Is that what you said? Yeah, 300 plus 45. That's exactly what I would do. So I would have the sine of 300. That's what I thought you said too.
I heard 3 times 10.
Me.
I did say that.
Oh.
Oh, I didn't say 3 times 10.
Oh, yes. Oh, now I'm seeing what you're saying. Okay. Don't multiply, add to 10. 10 times. I see what you're saying. 300 plus 45. So 300 could either be one of two. You could use it. Stop laughing at me. You could use it as 30 degrees. And there would be 10 of them. So that's 10 pi over 6, right? Could you also do 60 degrees? Which is also 5 pi over 3. Are 10 pi over 6 and 5 pi over 3 the exact same angle? Yeah. Does it matter which one you use? Absolutely not. So this is the same as the sine of 300 times the cosine of 45 plus the cosine of 300 times the sine of 45. Sorry, I ran out of room. All right, so we just said 300 degrees is 5 pi over 3. Yes? What is my reference angle if I'm talking about 5 pi over 3? Pi over 3. What's the sine of pi over 3? Radical 3 over 2. And it's in quadrant 4, so it is negative. Give Mitch a chance with those because he's figuring them out. So this is negative radical 3 over 2 times this cosine of 45 degrees. 45 degrees is what angle? Pi over 4. Cosine of pi over 4 is radical 2 over 2. Plus cosine of 300. So the cosine of 5 pi over 3. So what's the cosine of pi over 3? That's 1/2. And 5 pi over 3 is in quadrant. You guys be quiet. 4. Cosine is positive, so it's going to be a positive 1/2. That's exactly how you think about when you take those. Sine of 45 degrees, radical 2 over 2. I'm multiplying fractions, yes. How do I multiply fractions? Straight across, right? So negative radical 6 over 4 plus radical 2 over 4, which simplifies to negative radical 6 plus radical 2 over 4. Yeah? Okay. Sum and difference using radians. 6. Sine or cosine? Sine. Sum or difference? Difference. So this is the sine of pi over 5 minus 2 pi over 3. Yes? You have to get a what? Common denominator. So this is the sine of 3 pi minus 10 pi over 15. Does everybody understand how I got those? Common denominators? So this is the same as the sine of, gotta get a common denominator, so I have to multiply this by 3, so that goes by 3. This by 5, so that goes by 5. Try 7, please. That's all you can do. That's not an angle you know. Ooh. No, right? No. Yeah? We good there? 6 times 7 is 42. I know you did. It's okay. It's okay.
I got it right there.
What? The cosine of 13 pi over 42. All right. Do you want me to do 8 or do you want me to move into 9 and 10 when we actually have to find the angle? You guys tell me. I'll do 8. Or do you want me to come back to 8 if we have time? All right. Yes, I'm making it right now and I can do 8 really quickly at the end of it. Okay. 9 and 10. I think we should do both. I think we should probably do everything that's left. Okay? All right. So I need to find my angles and then condense. So here's what I would start off by doing. I would write as 5 pi over 12 equals, I know I'm using which 2? Which 2 have I always used? Pi over 3 and pi over 4, right? And immediately from there, I would write this over 12, and this is 4 pi plus 3 pi. I know, I haven't done anything yet. What? What we just did is you're condensing this one. You have to expand, find angles that you know. Like you don't know.
We're expanding this one?
Yep, we're expanding this one. It says to condense to get to a following exact expression. This is where you need to find angles that you recognize. So you have to use pi over 3 and pi over 4. On the previous one, you're just putting them together. They're not going to be angles that you know. Did that answer that, Josie, or not? Okay, so I need 5 pi over 12, right? Can I add this at all to get 5 pi over 12? No. So that means I have to subtract, right? So this has to be a subtraction problem. How am I going to get 5 pi over 12 if I subtract? Yeah. Multiply the 4 by 2. Yes, because what's 2 times 4? 8. So 8 pi minus 3 pi is 5 pi, yes? So this becomes 2 pi over 3 minus pi over 4. You guys, we did this last week. Do we remember doing these? From here, what am I going to use? Sum or difference, sine, cosine, tangent. And what am I going to use? Sum or difference? Clearly difference because I'm subtracting, right? Difference. Sine, cosine, tangent. Cosine, because that's what I need to find. Okay? So you need to do cosine difference formula. So this is the cosine of 2 pi over 3 minus pi over 4, which is the cosine 2 pi over 3 cosine pi over 4 plus sine 2 pi over 3 times the sine of pi over 4. Yeah? Now start finding them. Cosine 2 pi over 3. What is my reference angle? Pi over 3. What's the cosine of pi over 3? That is 1/2. And 2 pi over 3 is in what quadrant? The second. So the 1/2 is negative. Negative 1/2 times the cosine of pi over 4. Radical 2 over 2. That's one I think you guys should start to. That and tangent of pi over 4, like those should be fairly quick. Sine of 2 pi over 3. Reference angle. Pi over 3. Sine of pi over 3 is radical 3 over 2, and this is positive or negative. What? Positive because it's in quadrant 2, so radical 3 over 2. Times the sine of pi over 4. Radical 2 over 2. Multiply fractions. Negative radical 2 plus radical 6 over 4. Ooh. Okay, I'm going to skip 10 for a second. What?
How do we know, from the last one and this one, it's the same instructions, but how do we know what to,
These, do you know any angles over 15? No. Look, they look completely different though.
right.
These are expanded out, and this has nothing, this doesn't say anything about getting an exact value. This has condensed, and it should say, this should say get an exact value. It'll say get an exact value tomorrow on your quiz. Okay? I want to skip 10 for a second. Okay? Here's where the struggles began yesterday. When you see something like this tomorrow, you have to know what to do, and it cannot take you 5 to 10 minutes to figure it out. She knows I went upstairs and was yelling at Miss Smalley right after this bell. Okay, what does it tell me? It tells me the cosecant of alpha is 13 over 5. What else does it tell me about alpha? It's between pi over 2 and pi, which is what quadrant? It's your second quadrant. Because pi over 2 is 90 degrees. Yep. You go to 0 to 1/2 to 1 to 1/2 to back to 2. Your circle is into 4 quadrants. 1/2, 1, 1 and 1/2, 2, or 1, 2, 2. Good luck. You're going to be taking it on Monday then. The cosecant is 13 over 5. The cosecant is the reciprocal of what? Sine. So sine is opposite over hypotenuse. So my missing side length is what? What? Close. The number's right, the sign's wrong. It's got to be negative because you're going left. Okay? What do you mean you're going left? Your triangle's in the second quadrant, so your x value is negative. What quadrant is beta in? What? 4. Mm-hmm.
Wait, that's when we do the a squared plus b squared and the square root of c.
Yeah, but you're not going to have your calculator tomorrow. So remember, triangles that you should know are 3, 4, 5, leg, hypotenuse. 5, 12, 13, leg, hypotenuse. 8, 23, 24, leg, hypotenuse. I don't give you 8, 23, 24 tomorrow. But the other two you should know. 3, 4, 5, 5, 12, 13, triangles you should know. Tangent is negative 3, 4. So that is opposite over adjacent. Yes? Which one is negative? The opposite because it's going down. And my hypotenuse is 5. Now, what? Good. You're using these two triangles to be able to do the rest of it. Ready? So sine of alpha minus beta is this. Right? Straight off your paper. If you do not want to write that tomorrow to save time, then don't write it. Just start plugging in your values. The only reason I'm writing it today is so you guys can see what I'm doing. Sine of alpha. What is the sine of alpha? 5/13. Agree or disagree? Opposite hypotenuse, 5/13. What is the cosine of beta? Nope. Adjacent hypotenuse, 4/5. Minus the cosine of alpha. Yep, negative 12/13. And the sine of beta is? Now say it. Negative 3/5. Okay? Don't simplify anything, just multiply across. 5 times 4 is 20 over 65. Negative 12 times negative 3. When you multiply two negatives, you get a what? Positive. So this is still going to stay negative. 12 and 3 is 36 over 65. Simplify it to negative 16 over 65.
How did you go? I was right? The a squared plus b squared, but we're not gonna have a calculator.
Right. So I just told you 5, 12, 13 triangle. Leg, hypotenuse. Leg, hypotenuse. You are not going to have your calculators tomorrow. I think, honestly, if I gave you your calculator, it would slow you down, to be honest with you. You guys would be so worried about... You won't... I put money on it. Put money on it. If you just remember them, it's going to go a lot faster. All right, cosine of beta plus alpha. That is the cosine of beta, cosine of alpha, minus the sine of beta, sine of alpha. Do you want me to do this one or you want me to do tangent? Okay, so this is the tangent of alpha minus the tangent of beta divided by 1 plus tangent alpha, tangent beta. What is the tangent of alpha? It's negative 5/12. Minus. What is the tangent of beta? Yep, negative 3/4. Divided by 1 plus negative 5/12 times negative 3/4. From there, there's no more trig, right? Absolutely no more trig. What do you have to do on the top? Common denominator, yes? Can I give you a hint? Some of you are going to see 12. which is fine. But if you multiply the denominators, it makes it easier when you get rid of this. So just always multiply them. So I'm going to make the common denominator 48. So this is negative 20. And this becomes a positive 36. Here's why. Multiply this by 4, yes. Multiply that by 4, yes. Multiply this by 12. And it's negative, so 2 negatives is a positive. Everybody see what I did there? Divided by. You have to get a common denominator down here as well. So this is 48 over 48. I'll move this. Plus 15 over 48. Yeah? So this becomes 16 over 48 times 48 over 63. What do you notice? 48's cancel, so your final answer is 16 over 63. Yeah? Okay, here comes the fun stuff.
No, I'm kidding.
What? Start working on the first one. Sum or difference, sine, cosine, tangent. That's the first thing you want to ask yourself. So, sum or difference. Actually, I would go sine, cosine, tangent. Sine, right? Sine and cosine together. Sum or difference? Difference. So this is the sine of 3y minus what? Negative 5y. What are we going to do? You're going to add them. So this is a sine of 8y. You do not know how to do anything more than that. You will eventually. Right now you don't. That's it. 15, sine, cosine, tangent. Tangent. Sum or difference? Difference. So this is the tangent of 2 beta minus 6 beta. Yeah? What are you going to do? What? Combine them, right? So this is the tangent of negative 4 beta. Now, I am fine with this. But, is there a negative in my angle? Yes. So it should come, like, tomorrow, if you leave it like this, that's fine. But even odd, this actually should be written like that. I am fine with the first one tomorrow. Once we get to the chapter test, I am not fine with it. Oh, yeah. We still got like 2 more sections to do. Oh, yeah. All right, 16. Are these angles that you should know? Yes. What is the cosine of pi over 2? Listen to me. Use your cheat for cosine. When we graphed cosine, what did you write on your paper? What did you remember? Max, 0, min, 0, max, right? Those are your angles. Max goes with 0, 0 goes with pi over 2, negative 1 goes with pi, 0 goes with 3 pi over 2, and 1 goes with 2 pi. That is how I remember them. So the cosine pi over 2, max 0. So this is 0. Well, anything times 0 is what? 0. So that's all gone. Sine of pi over 2. 0, max. The sine of 0 is 0. So the answer to this is 0. Sine of alpha times the cosine of pi over 2. What's the cosine of pi over 2? 0. So that one's gone. Cosine of alpha times the sine of pi over 2. What's the sine of pi over 2? 1. So this is like saying negative cosine of alpha times 1. So this is just negative cosine alpha. Yeah? Here we go. 18. Verifying. Sine, cosine, tangent. Cosine, some difference. What? Difference. So this is the cosine of x times the cosine of pi plus the sine of x times the sine of pi. Just using your formula. Yes, no, maybe. Okay. Cosine of x we can't do anything with because we don't know what x is, right? Cosine of pi. Max, 0, min. What is the cosine of pi? -1. So this is the cosine of x times -1 plus. Do I know anything about the sine of x? Nope. Sine of pi. 0, max, 0. So I have negative cosine of x equals, is that right? It is because you have an even odd. Negative cosine is the same as cosine. I'm not going to be that mean tomorrow. I won't make you use even odd tomorrow. Try 19. Take 2 minutes because I want to get through 20 and 21. Take 2 minutes to do 19 real quick.
Do we use notes tomorrow?
No.
What made you stop doing those?
Because I don't give you graded assignments all the time. Because honestly, you have your notes in front of you. They're your flip book.
I don't remember the last time we had one.
Leave her alone. No, this one should be negative sine of x. Oops. That should be negative sine of x. Smith typo. Should be negative sine of x. That's how you're going to do it. Okay? Yeah? All right. What time is it? 20 or 21? 20? Okay. So I'm going to use difference formula for tangent, yes? So I'm going to have the tangent of theta minus the tangent of 3 pi over 2 over 1 plus the tangent of theta tangent 3 pi over 2. Okay, can I do anything with the tangent of theta? No. 3 pi over 2. Here's how I do this. I do my sines and cosines cheat. Let's do the sine cheat because it's tangent is sine divided by cosine, yes? So my sine cosine is 0 max. Have you guys ever seen me use my fingers over here? But do you realize, like, when I'm doing that, I'm doing my cheats in my head. Like, I don't know the tangent of 3 pi over 2 off the top of my head. I literally go 0 max, 0 min. Okay, so sine is -1. This one I don't like. No. This one I don't like. But I would say sine is -1. And then the cosine would be 0. So that's undefined. Right? So you can't do that. So this is not the best example. Can I do 21? This is actually undefined. Because it'd be minus undefined, which doesn't make sense. And you'd have 1 plus undefined, which doesn't make sense. Nope. Okay. Would you like me to do 21 then? Okay, here we go. Cosine of x, cosine of pi over 6 plus sine of x, sine of pi over 6, plus, what are you whining about? Sine of x, cosine of pi over 3, there's not that much, minus cosine of x, sine pi over 3. Boom, boom. You're just a whiny butt.
Me?
Yeah,
Me.
I didn't stutter.
Oh. Damn.
All right, what's a cosine pi over 6? This is fun. No, what's a cosine pi over 6? You do complain a lot. We just haven't had her in 2 days, so I'm being nicer right now. I shouldn't be. What's a cosine pi over 6? Radical, what? Yep. So this is radical 3 over 2 times the cosine of x. Plus, what's the sine of pi over 6? 1/2 plus the 1/2 sine of x. What's the cosine of pi over 3? That's 1/2. Gosh, you guys are so smart. What's the sine of pi over 3? Negative radical 3 over 2. Well, I mean, Alexis can tell you what I went and told Smalley yesterday. I'll wait until I stop my video. Yeah, I went upstairs to whine to Smalley about something. I also had to, I didn't go up there just to whine. I did make copies. Does anybody notice anything? There are 2 1/2s. If you have 2 1/2s, that is woo! So I know I have sine of x. What else do you notice? The cosines cancel. Are you done? You are done.